Have you ever thought about the exact moment something becomes something else? Not like a big sudden explosion, but a slow, gradual change. We're about to dive into a puzzle that starts with just one grain of sand, but believe me, it ends up questioning the very logic we use to understand the world. It's called the Sorites Paradox, or, the paradox of the heap. So this riddle, it's a classic example of what's called a sophism, which is basically a fancy word for an argument that uses perfectly sound-looking steps to lead you to a conclusion you know deep down is just plain wrong. Let's see how it pulls off this little magic trick. And here it is, the question at the very heart of it all. Seriously, think about it. One grain of sand. That's not a heap, right? Obviously. Add another grain, still not a heap. So where's the line? When does it happen? Is there some magic, specific grain of sand that flips the switch from not a heap to a heap? Okay, let's just break down the logic step by step. We start with a premise we can all agree on. One grain is not a heap. Easy. Then we add a rule that seems just as obvious. If you have a bunch of grains that isn't a heap, adding just one more single grain isn't going to suddenly make it a heap. But here's the catch. If you apply that simple rule again and again and again, you're forced to accept a totally ridiculous conclusion, that a million grains of sand, a whole beach dune, is somehow not a heap.
And that is the paradox. We've got this chain of logic where every single link in the chain feels solid, unbreakable even. Yet the final result is just absurd. It completely contradicts what we can see with our own two eyes. So something in that chain has to be broken. The question is, what is it?
So where did our logic go off the rails? Well, to find the flaw, we've got to look really closely at a fundamental rule of reasoning, a rule that this whole paradox is designed to push right to its breaking point.
This rule is called transitivity, and it's basically a bedrock of all logic. Think of it like this. If a blue block is the same size as a red block, and that red block is the same size as a green block, then it's a no-brainer. The blue and green blocks have to be the same size. It just seems unbreakable, right?
Well, here's the twist. It turns out there are two different kinds of equal. In the clean, perfect world of pure logic, equality is absolutely transitive. But in the messy, real world of our senses, that rule completely breaks down. A pile with 10,000 grains might look indistinguishable from one with 10,001, and that pile looks the same as one with 10,002. But you can definitely tell the difference between a pile of 10,000 grains and one with 20,000. Sensory equality is not transitive.
So this whole idea of things being indistinguishable to our eyes, it has some properties of equality, but it's missing the big one. A pile looks like itself. That's called being reflexive. If pile A looks like pile B, then pile B looks like pile A. That's symmetric. But like we just saw, it is absolutely not transitive. And that right there, that's the critical failure. That is the crack in the foundation that the entire paradox is built on.
You see, this isn't just a fun little logic game. It actually reveals a really fundamental conflict between the clean, black and white world of formal systems and the messy, continuous world our senses are actually living in.
And this wasn't just a puzzle for the ancient Greeks either. The great mathematician Henri Poincaré saw this as a really fundamental problem. He realized this whole thing goes way beyond sand. It's about how we perceive the world. These tiny, unnoticeable changes are constantly adding up until, bam, they create a large, undeniable difference.
He actually gave this a fantastic name, the discontinuity jump. It's that exact moment where our brain, which has been smoothly going along with all these tiny changes, is suddenly forced to admit that, whoa, a big boundary has been crossed, even if it can't point to the exact step where it all happened.
So the paradox isn't just a trick. It's an empirical fact. It shines a big spotlight on an unavoidable contradiction that pops up whenever we try to apply the black and white rules of classical logic to all the shades of gray in the real world. And this isn't just some philosophical curiosity. It has huge consequences. There's a super powerful mathematical tool called induction, and it's built on this exact idea of transitivity. It works like a chain of dominoes. Knocking over the first one guarantees the next one will fall, and so on. The Sorites Paradox shows us that in the real world of vague ideas, some of those dominoes are just too far apart. The chain breaks.
So if our standard go-to logic gets completely broken by something as simple as a pile of sand, what's the solution? I mean, do we need to invent a whole new way of thinking?
This is the huge question that philosophers have been wrestling with for, well, centuries. Is reality itself just messy and vague, or are the logical tools we're using to measure it just not the right ones for the job? And more and more, the evidence is pointing to our tools.
So, okay, if we were going to design a new logic, what would it need to do? What's on the checklist? Well, first, it would have to actually embrace vagueness, instead of trying to pretend it doesn't exist. It would also need a built-in rule that just accepts that, hey, our ability to tell things apart isn't always transitive. And ultimately, its main job would be to finally bridge that gap between the world as we see it and the world as we try to describe it with our theories.
One really clever solution that's been proposed is something called epsilon transitivity. It basically redefines what equal means. It says two things are equal if they're close enough. If the difference between them is smaller than some tiny, predefined margin for error, which we call epsilon. This way, a whole bunch of tiny, close enough steps can finally add up to a big difference that is definitely no longer close enough. And this idea has led to whole new ways of thinking, to new frameworks like the logic of indiscernibilities. See, unlike classical logic, which kind of pretends that perfect precision exists everywhere, these new systems start from the assumption that our measurements and our senses have limits. They build the fuzzy reality of the world right into their core rules from the get-go.
So what starts as a simple, almost childish riddle about sand ends up forcing us to question the very tools we use to make sense of everything. It suggests that vagueness isn't some bug in the system, but maybe it's a feature of reality itself. And that leaves us with one last big provocative thought. If our fundamental logic can be broken by a simple heap of sand, where else might our most basic assumptions be failing us?